will continue with us when he is in.
Okay. Go ahead.
Yes. So this is the workshop that you registered for or invited to, which is the Tiny Edge Machine Learning Challenges and Opportunities for your IoT applications. Thank you to each one of you for being here with us today. We are very pleased to be able to welcome those you that have been with us for a long time now, as well as those who are new to the Hashemite University and the Royal Academy of Engineering. So today is the first online workshop and meeting for our funded project entitled Ultra Low Cost Machine Learning Enabled IoT Devices on the Edge. And we are so proud here in the Hashemite University and the Faculty of Engineering to be able to host it today in this Zoom online meeting. So the aim of the workshop is, as the aim of the window of Distinguished International Associate Projects, is to spotlight the capabilities of the low performance edge sensor node controllers by using tiny machine learning algorithms in order to reduce the expected congestion and capital expenditure of the IoT infrastructure, especially in the agriculture applications. In the context of smart farming and water management in Jordan, we believe that this will ensure that IoT agriculture is inclusive, not to reach only high-tech farming industry, but also the small and medium-sized poor farmers. This workshop is a kickoff workshop, mainly with some technical talks on tiny machine learning, and from many countries, Jordan, UK, Italy, and the Gulf. Hopefully, the speaker from Italy will be in with us. He sent me that he has some technical problems, and we hope that he will be with us. This is a project that I'm leading from the Hashemite University and is funded by the Royal Academy of Engineering in the UK and also funded by the Hashemite University under the title Ultra Low Cost Machine Learning. The workshop will highlight the state-of-the-art technologies in tiny machine learning, the funding windows by the Royal Academy of Engineering, as will be presented by Mr. Shane McHugh from the Royal Academy of Engineering, the head of International Partnership and Collaborations in the Academy. It will highlight also the collaboration opportunities that may raise the efficiency of students in engineering faculty and information technology through advanced research graduation projects, and to provide them with skills that qualify them to the labor market through a series of workshops such like this and courses, in addition to networking with a number of international universities, research institutions, and local market companies. Chances Media have all chosen us to be a part of this workshop due to mutual passion for us, for our universities, companies, and the academy. Your passions help us all to unite, gather, and the energy of this workshop will create what will allow us to achieve our individuals and targets, as well as the collaboration goals. During the next few months, we will be learning via several workshops, seminars, special events, and conferences through our planned activities in this project, where you will be able to join in and get hands-on experience. I hope that these will help you who are interested in growing their knowledge and strengthening the cooperation through this kind of networking events. At this stage, I would like to pass my grateful thanks to the Royal Academy of Engineering for the support and the funding and believing in us here in the Faculty of Engineering at the Hashemite University through several funding windows that funds multiple projects in the Hashemite University. Mainly and namely the Distinguished International Associate window that this project is funded by, and the other one, which is Transforming Systems Through Partnership, the TSP, which is known in Jordan here as Newton Faraday window. So a very warm welcome to each and every one of you. If you have any question, suggestion, clarification, or just want to say hi, you can raise your hand and ask your question or send us on the chat. Well, I don't want to take too much of your time, and I need to leave some time for Professor Fawaz Abdulhaq, the president of the Hashemite University, who is always a strong believer and supporter to the research efforts that we are doing, and who is looking always towards strengthening the collaboration with the different entities. And I think this workshop is a good start at the Hashemite University with the Royal Academy of Engineering to build upon our previous collaborations and jump into more and more strong and direct collaborations. Dr. Fawaz, the mic is yours.
I think it's muted.
Okay, yeah. Yeah, can you hear me?
Yes.
Thank you very much indeed.
Yes.
It's my pleasure to be with you. I am not an engineer, but I am a linguistic engineer. We have so much in common between linguistics and engineering. From day one, when I was assuming the leadership of this university, Ali Hayajna in particular, and the Faculty of Engineering have won my admiration. They're great guys. They are leading university. So the Faculty of Engineering for me is really indeed a milestone, a landmark that are achieving something that will lead the university from globality, from locality to globality. So, and second, I was so happy to see many faces who are gathering with us, attending, including my Vice President, Professor Dr. Khalid Al-Hayari, who is my Vice President for that faculty, and he's coming from the Faculty of Engineering. And just to let you know, more than 10 people in administration are coming from engineering. There is no wonder. Therefore, we are having a kind of envy from other faculties. Why engineering in particular? Engineering are not only for engineering purposes, they are engineering the generation. I think we need this new definition. Let me go back to what has been written to me to be said in your committee. I'm really happy to be with you in this workshop, which is organized by the College of Engineering and entitled Tiny Edge Machine Learning Challenges and Opportunities for IoT Application. And I mentioned Ali by his name when I met his Majesty King Abdullah in the 19th of April 2020, when we were talking about his project and the application of that project in the arid land, the role of using drones, developing certain specific technology for, and this is actually the tiny coming from this. So, and also I would like to welcome you all the attendees from all over the world, from inside Jordan and outside Jordan. Moreover, I welcome the partners and event speakers participating in the pioneering project supported by the Royal Academy. And I will pause here. They are Royal Academy and we are Hashemite, we are royal too. So this is one of the common elements between the two royals, the Royal Academy and the Hashemite University and the Royal Engineering faculty at Hashemite University. Thank you for the support and funding provided by the Royal Academy through the various programs for a number of projects from the Hashemite University and in various Jordanian universities. As you know, the Hashemite University is oriented toward achieving an academic pioneering position and excellence in university teaching, scientific research at both national, regional, and to serve society through its educational functions, and to participate in achieving the goals of the comprehensive national development through preparing loyal and dedicated men and women who are not only technically competent in their professional fields, but also lifelong learners who have a broad vision, loyalty to their nation, and a sense of civic and moral responsibility and devotion to the fundamental values of human life. We are also interested in the Academy partnership with the Jordanian higher education sector to enhance and develop capabilities within Jordanian higher education and research institutions, and to enhance the output in education and research and engineering innovation by strengthening industrial links and benefiting from the UK expertise, especially in every important areas of the global, local, such as artificial intelligence and the Internet of Things. And I hope that this is going to be a department someday, sometime, either within the Faculty of Technology or the Faculty of Engineering. And here I would like to point out that we are interested in these scientific disciplines and their application to serve all productive and industrial sectors. We have recently developed an academic program in artificial intelligence, and we have centers at the university concerned with innovation, excellence, big data, and artificial intelligence, and we seek to develop all of these through the projects. Last but not least, I extend my thanks to the Royal Academy for the unlimited support for their projects and ideas of faculty members of the Hashemite University, and we look forward to further cooperation. I also thank colleagues from the College of Engineering for organizing this workshop and for their creativity in this pioneering project. We promise that we all continue to provide absolute support for this collaboration. Thank you very much indeed for listening, and wish you all the best.
Thank you.
Okay, thank you, Professor Fawaz, and thank you for all of your participants here in the workshop. As the schedule told us, the time is now for Mr. Shane Mackey from the Royal Academy of Engineering to give his talk. Mr. Shane, the mic is yours.
Thank you very much, Dr. Ali, and I'd love to thank you and Professor Fawaz for an excellent introduction and for the kind words you've said about the Academy's international work. I'd like to take a few minutes to talk about what the Academy does internationally, focusing particularly on some of the opportunities Dr. Ali Hayajena mentioned earlier on about that are available to researchers from Jordan. I'd like to share my screen. That's okay, Dr. Ali?
You as a host.
Oh, yeah, okay. Thank you. Let me do that now, thanks. This will stop other screen sharing. Yes, that's okay, isn't that right? I can just...
Yeah, that's
fine. Okay. Share. So can you see a presentation now? Yes? Has that worked, Dr. Ali?
Not yet. Yeah,
Yes.
it's okay.
It's working now?
Yes.
Yes, okay, thank you. So yeah, I'll just give a short presentation on our international activities. And if I move on. So the Academy's mission, global mission, is to advance engineering's contribution to a safer, inclusive, more sustainable world, with a particular emphasis on tackling the global challenges of our time. And we have a really global portfolio of programs with a lot of focus on developing and emerging countries. We have recently adopted a strategy to 2025 that puts the global work at the heart of what the Academy does. And its goal is to harness the power of engineering for a sustainable global society and an inclusive UK economy. And there's three things we do that really help address those goals. Fostering talent and diversity, promoting innovation, and influencing policy in the public. And I'll go quickly through what we do that meets each of these goals. But obviously, we can only meet these goals with key partners around the world. And I'd like to pay tribute to the Jordanian Ministry and particularly to the Hashemite University for being such excellent partners. I'll talk very quickly about our work in innovation. We have two real goals here. The first is to stimulate better, so more effective international innovation collaborations. So not just to accelerate development, but also to ensure that to accelerate the deployment of tools to advance sustainability. And we also want to increase our support for excellent researchers and entrepreneurs across the world, developing innovations targeted at sustainability challenges. And how we do those things? So the Transforming Systems Through Partnership program that Dr. Ali spoke about earlier is our main vehicle for stimulating more effective international innovation collaborations. We work in partnership with Jordan and 6 other countries around the world in this. And really, it's a mechanism to allow a university in the host country to catalyze a partnership of not just academia, but industry, government stakeholders, SMEs, and civil society stakeholders, and mobilize them around a national challenge. This program at the moment, we are in the UK, we're going through a 3-year spending review across the whole of the country. And as you may have seen, this program was previously funded through our aid development funding, which has reduced because of the impact of the COVID pandemic in the UK. However, we are putting bids for government to expand this program under other streams of money, and hopefully we will have good news about future rounds of this scheme later in the year or early in 2022. We also provide support for researchers and entrepreneurs developing sustainability innovations, and that's another area where we partner currently with Jordan on what's called the Leaders in Innovation Fellowships. So this is really an innovation and entrepreneurship boot camp for engineering researchers with an innovation that tackles a sustainable development goal that they're trying to commercialize. And it's a very intensive boot camp, and at the end of it, along with a network in the UK and a slide deck, because there's lots of training on both running a startup and how to ensure finance for the startup. The other thing we want to see is a mindset change spreading around academia, and so that across engineering researchers, there's an understanding that entrepreneurship is something that adds value and is not a kind of a side alley. It's an important part of an engineering research career. We also run a couple of Africa-focused, so it's sub-Saharan African-focused programs, the Africa Prize for Engineering Innovation, and Project Care, which was a program to help entrepreneurs in sub-Saharan Africa during the pandemic. I'll mention one Africa Prize winner, last year's Africa Prize winner, because her work is very related to the topic of this conference. This is Charlotte Negessian from Côte d'Ivoire, and we're delighted to support her. Her innovation called Base API was a facial identifying technology, so it allowed finance companies in sub-Saharan Africa to verify identities through facial recognition, through essentially a camera phone on the person's phone, and it was it used AI, but it was specifically geared towards recognizing African faces. And it's an example, I think, of low-cost machine learning interventions in low-resource environments that really add value. I'll talk very quickly about our policy and engagement work. Again, the work we do is generally in partnership with engineering academies around the world, and with global engineering stakeholders. And it's about embedding a systems approach in responses to sustainability challenges and developing strategic alliances of engineering stakeholders to inform and engage policymakers and really improve global engineering leadership on the challenges that matters to the engineering community. And I'll very briefly talk about this. We run 3 missions globally, which are active around the world. It's not in specific partnerships with specific countries, around better management of safer complex systems, improving the end of engineered life of engineered objects. Especially, we're focusing at the moment on large-scale objects, ships, and maritime infrastructures. But we have also done a review of global waste streams, and we're carrying out a piece of work for COP27 in Africa on the challenge of open burning and how open burning of waste contributes not just to health and safety problems, but also contributes massively to global CO2 emissions. And then pandemic preparedness, helping engineers through with innovations that address the pandemic and assessing how the engineering community performed. And we also have partnerships specifically with a number of countries on a number of themes. An example of the safer end of engineered life work, global shipping. 90% of global ships are decommissioned in a very informal way on 2 or 3 beaches in India and Bangladesh. And what we are trying to do is work with stakeholders within the industry, within manufacturing, and also within those countries to improve the safety of the process. And then I'm going to say a little more about talent and diversity, because that is where the Distinguished International Associates Program that Dr. Ali is part of sits, and that is now open for application. So I'll tell you a little bit more about that. Again, our goals here are to mobilize the global engineering community, create strong international alliances to support sustainability, support capacity building in engineering as a priority, and we do a lot of that in sub-Saharan Africa. And then there's also a UK element, ensuring that the UK workforce is world leading and truly inclusive. We do the world leading and truly inclusive workforce through a global talent visa scheme, which allows engineers who are emerging talents or global talents from anywhere in the world to come to the UK with a pathway within 3 years to settlement. And also the Distinguished International Associates Program, which I'll talk about in a second. We support capacity building, mainly in sub-Saharan Africa, through programs addressing higher education, institutions building their links with industry, and through a program called Africa Catalyst, which supports professional engineering institutions, and a new program on engineering skills where they're most needed, which tries to ensure that all countries in sub-Saharan Africa have the engineering skills safety skills at their disposal to safely install, maintain, and repair critical infrastructure. And we also run a number of programs bringing researchers from all countries together and from all engineering disciplines together around a common challenge, and they're called Frontiers programs. We run a bigger version of this with the US and China called Global Grand Challenges Summits that's more focused on students. Finally, I'll just say a few words, if I may, about the Distinguished International Associates Program that Dr. Ali is one of our treasured associates this year. It's a new program, and it is open to excellent international engineers working across all sectors at the cutting edge of engineering research or innovation, who already have collaborations or connections to the UK, but they want to intensify those. And what it aims to do is really support and strengthen collaborations and engagement between awardees and their peers in the UK engineering community, particularly broadening out those links from maybe one or two collaborators to a broader range of UK universities and engineers. We also provide funding and communication support to empower the associates to broaden and demonstrate their links with the UK and the Academy. And we promote their activities, particularly where they align with those Academy objectives of sustainability for all, as this conference very, very clearly does. And we also hope to build a peer support network of these associates to help stimulate the engineering communities in the home countries and facilitate opportunities for the alumni to build their own links, be it in research or innovation or policy, with the whole of the UK's engineering community. So there's funding of £10,000 in the UK, which is about €12,000, for up to 24 months to strengthen collaborations with the UK. And we are starting up an associates network, so it allows participation in that, but also you get tailored support and engagement with the Academy to pursue your project. So round 2 is now open. Round 1 was a pilot round, and it was only open to people who had a previous association with the Academy, as Dr. Ali did through a Transforming Systems Through Partnership project. This round is open to any engineer, with any excellent engineer with strong links with the UK, and they will join our first cohort in a growing international network. The deadline for applications is the 8th of November, 2021. And there are links on the presentation, which I can ask Dr. Ali to share around on our website and a program team email for any questions. Thank you very much for listening. I'm now going to stop sharing and hand back over to Dr. Ali.
Thank you, Mr. Shane, for being here with us today and delivering your talk. And we are very happy here in the Hashimat University to be part of partnerships with the Royal Academy of Engineering. Since we have some time, I'd like to also, as scheduled, put the floor for Professor Auni, the Dean of the Faculty of Engineering in the Hashimat University. And if we have some time for a short discussion with you, it will be after Dr. Auni's talk. Dr. Auni, the mic is yours.
Thank you so much, Dr. Ali, for this opportunity. In fact, many thanks to the President, our President, Professor Fawaz Abdelhaq, for his support and attendance of this workshop. This workshop is aligned with his vision of supporting every effort to cooperate globally, as well as a big thank, in fact, to our colleague and Vice President, Professor Khalid Al-Hyari, who is a specialist, in fact, in engineering and construction management. And one of his research interests is the artificial intelligence. And he used to deal with, since 20 years, with genetic algorithms and neural networks. And this is why he is very interested in this workshop. And many thanks, in fact, to Mr. Shem from the Royal Academy of Engineering for being with us and for his comprehensive talk about the activities and programs of the Royal Academy. So thank you very much for this opportunity to talk to the participating friends and speakers in this important workshop, which deal with a very important topic, namely the artificial intelligence and Internet of Things and their applications as well. It's my honor, in fact, to be with you all. I would like to welcome all attendees and partners from all over the world and it is a real opportunity to thank and appreciate the partnership with the Royal Academy of Engineering in UK. We are proud, in fact, as Dr. Ali mentioned, that in the College of Engineering, we have a number of projects funded by the Royal Academy. We fully believe that holding such specialized workshops and such partnerships aligned with the vision and mission of our Faculty of Engineering, in which we aim to prepare highly qualified graduates for careers in the engineering profession, providing them with a broad, stimulating engineering education, professional skills, and knowledge that will enable them to succeed in their future career, and to prepare graduates to engage in work environment, handling different challenges of local, regional, and global marketplace. And also in our high postgraduate programs to conduct research that leads to recognized scientific contribution in applied field globally and locally, which support the comprehensive sustainable national plans in Jordan. The Faculty of Engineering is committed to provide students with up-to-date knowledge and practices toward advancing Jordan and the region in the field of engineering technology. We also committed to research that leads to better solutions for the industrial sector in engineering-related problems. There is no doubt that artificial intelligence and the Internet of Things are among the most important skills and knowledge that our students must be able to use to raise their competitiveness and employability in the labor market. In all of our engineering programs, and we have in fact 8 engineering departments or programs, one of the main educational objectives are to produce graduates who can apply breadth and depth knowledge, critical thinking, and problem-solving skills to excel in professional careers and address contemporary issues related to the engineering discipline. The outcome of this project, which is led by Dr. Ali, and this workshop are fully compatible with this main objective of the engineering faculty. Moreover, this project and the knowledge of AI and IoT are crucial to be employed in the Hashemite University, where we adopted a comprehensive strategy for environmental management, which is directed to a green campus. The strategy is a multi-spectrum of practices enabled and implemented throughout the campus in the Hashemite University. This strategy can be summarized as the following: renewable energy, energy efficiency, water management, pollution mitigation, and capacity building. These practices were realized into the fabric of the campus in all infrastructure projects and expansions, along with all social and academic procedure. It is necessary to emphasize that the Faculty of Engineering play a crucial role in achieving this vision. We are very interested and supported by, we are very supported by the university administration, represented by our president, Professor Fawaz Abdel Haq. And we are very interested in the fourth industrial revolution. And hence, in fact, next week, under his patronage, under the patronage of Dr. Fawaz Abdel Haq, we will sign 3 MOUs with the most important Jordanian companies and institutions working in the field of artificial intelligence, Internet of Things, and robotics. And in fact, this project, in which we are attending this workshop as a part of it, will integrate our undergraduate students through the graduate projects. And it is to be mentioned here, as Dr. Ali told me, that 15 of our graduate students They are already work under the title of this project. And we have 2 technical workshops have been held and 3 indirect international scholarships under processing to be granted to students to complete their studies in international universities with direct coordination by Dr. Ali Hayajne and the funding institution, all under the benefit of this fund. This project will definitely contribute in transforming knowledge between UK and our Jordanian university through strong and efficient collaboration. This project is linking, in fact, universities from Jordan, from UK, Italy, USA, Vietnam, and other companies in Jordan. One of them is Larimar and the Way for Innovate. And it's to be mentioned here that the founder of Larimar company, she is engineer Abir al-Bashiti, and she is one of our graduates. And in fact, we are proud of Engineer Abir. Finally, I would like to thank the Royal Academy of Engineering and the representative, Mr. Shein, who's the head of the international partnerships, for being with us today. And in fact, I have to mention that, Mr. Shein, that we are looking forward for the opportunity for direct collaboration agreements with the Royal Academy to fund projects by researchers from the Hashemite University and from the Faculty of Engineering. We are eager to this opportunity and for this collaboration with direct impact collaboration with the Royal Academy. Thank you so much. Thank you, Dr. Ali, and floor is yours. Thank you.
Thank you, Professor Aouni, for your talk, and thank you all for keeping listening with us in this workshop. I think we have a couple of minutes for any discussion. If anyone of you has any question, any clarification, or just want to say hi, then you can unmute yourself and just talk whatever you want.
Okay, Dr. Ali, if you allow me, just a couple of minutes.
Yes, you are more than welcome. I wanted to ask you to intervene in this workshop, but the mic is yours now, Dr. Khalid.
First of all, I would like to thank our president, Professor Fawaz, for attending this workshop. And I want to thank you, Dr. Ali, for taking the lead in organizing this workshop. I want just to strengthen the importance of the topic of this workshop. We are looking for innovative research in the Internet of Things, artificial intelligence, and I would like to just to call for an interdisciplinary research focusing on artificial intelligence applications for real things, and also for Internet of Things. Thank you again for taking the lead in organizing this workshop, and we are looking forward for more workshops in the future, inshallah. Thank you.
That's fine. Thank you, Dr. Khalid, for this. And I have a plan to speak about the multidisciplinary applications for artificial intelligence and machine learning, especially on the edge, because when we say the edge, we say ultra low cost and ultra low performance capabilities of the controllers and the sensor nodes. So employing or harnessing these kind of edge devices is very crucial and important to deploy and develop commercial products, which is always the target and the motivation of the engineering, especially when we are talking about the Hashemite University, which is one of the leading universities in the engineering. This call is more than welcomed, and we have in our activity plan another workshop, and we hope so that this workshop will be a physical workshop in Amman or in the Hashimat University itself. I will send you an invitations once it's settled and organized. It will be, I think, in next May, the next year. So I would like to thank you also again for being with us. Another couple of minutes for anyone who wants to ask any question. Since Mr. Shane and Dr. Auni and Dr. Khalid is with us today, I think any question will take its direct orientation to the managers and the leaders in the university and the Academy of Engineering. You can unmute yourself and ask any question directly.
I've just wrote my question in the chat.
Yeah.
I asked, will this collaboration take effect in the future? And was there any project achieved, or is there any project currently in progress between these collaborating institutions?
Yeah. Okay. So as I mentioned before, this and on the website of the project and the workshop, this project and workshop is part of two projects. This project is through the Distinguished International Associate window under the name of ultra low cost, low performance edge devices, and it's currently going on, and we still have around 18 months in this project. There is another project through the Newton-Hardy project windows and for drone assisted micro irrigation, and when we talk about artificial intelligence and machine learning, it takes its part in these projects very strongly. So the collaboration is always open. You can just send me an email or send me a message, and then I will organize for a meeting and physical meeting or online meeting or a special event to talk about any further and future collaboration. This workshop is part of the, as I said before, part of the window of Distinguished International Associate, but without being funded via the Newton-Hardy project or the Transforming System Through Partnership projects, then this DIA will not be funded, because to be funded with a Distinguished International Associate project, you need to be an alumni of the Royal Academy of Engineering. And I were one of the alumni through the Newton-Hardy project. So the Newton-Hardy project, I think, will be opened in a couple of months if things goes as usual. And the call is open for anyone who is listening, or he will listen to this recorded meeting, to contact us and to collaborate. This is my answer to this, and thank you for being here with us. So I've been waiting for Dr. Massimo from Italy, from the University of Mediterranean of Calabria. I'm not sure that he is in with us. He told me that he has some technical issues and circumstances. I will put right now Dr. Sayed Ali Reza from Leeds Unit. Okay, Shane, you want to?
Oh, sorry. Just thank you very much, Dr. Ali, for your answer to that. Just to say two things in addition. That was a very good roundup of the projects that are on offer. Two things in addition. The Distinguished International Associates from this year, you do not need to be an alumni of the Academy. That was just of Academy programs. That was just the case in the first year, which was a pilot year. So the current round is open to any excellent researcher with a project who already have connections or a project with the UK that they want to intensify. And then secondly, just to say, obviously, In the UK, there's a big spending review in progress, and we won't know until it finishes what the outcomes for things like the Newton Fund will be. We have obviously submitted all our bids, and we hope, even if it doesn't go ahead in the current form, that we'll be able to have some kind of transforming systems through partnership future call. It might not be under the Newton Fund or under the aid budget. And we will definitely let you know as soon as we find out, but maybe there may be a pause in calls early next year, while the results of the spending review filter through.
Okay, thank you, Shane, for clarification, and I'm very pleasant to hear that the Distinguished International Associate is open for any researcher who is passionate to do any collaboration with you. From Hani, can we elaborate more about what we mean when we say the project themselves would be in a connection with the UK?
Yeah, I can do that, and it's the broadest possible definition of that. So some research collaboration with the UK, either existing or previous, that you want to build upon. We would also accept, for example, someone who did their PhD in the UK and retained strong links with the university, that department they worked with, and wants to start a new project that will kind of build on those links. So it's not so the criteria are not so much about they're about the purpose of the collaboration, not about the existing strength.
Yes. Yeah. So thank you, Shane, for this. And yeah, even if you are a PhD student, master's student in the UK, and you went back to home for then you will be given the opportunity to apply for a Distinguished International Associate program and strengthening your collaboration with your previous supervisors or previous friends in the UK, friends as researchers, for sure. So I think we've taken more time in this discussion, and thank you, Shane, and thank you all of you for this wonderful discussion and more knowledgeable discussion. I think Massimo is not here yet. We will put him in hold, and we will go to Dr. Sayed Ali Zaidi from the University of Leeds. He was my ex co-supervisor in the PhD in the University of Leeds. And he is going to talk about, and the title of his talk is Sensing the Pulse of a City, Practical Consideration for IT Deployment and Role of Machine Learning at the Edge. I think the title of this talk is very interesting, especially for those who are interested in smart cities. And when we say smart cities, it takes all the parts of engineering in it. When we talk about the Hashimite University, we have 8 departments with many programs. All of them might be interested in this talk. Dr. Ali, if you are ready, the mic is yours.
Okay, so thanks, Ali, for inviting me today to deliver this talk. Thanks, Shane, for supporting this initiative through Royal Academy of Engineering. As you guys have mentioned, this sort of program is really a good segue into supporting students who have graduated from University of Leeds, for example, in this case, and trying to establish their independent research in a particular area which has national benefits as well associated with it, and it enables us to work closely with Hashimite University in this instance. So it's really exciting program, and very glad to be part of it. Very thankful to the leadership of Hashimite University, who in first instance sent very excellent students like Ali Hayajane to Leeds, and then that led on to all these initiatives. So really thankful for supporting these initiatives from Hashemite University. I sort of wear the dual kind of hat because I'm an academic at University of Leeds as well, but I also have very strong ties with spin-offs in the region. So what I will be talking about today would be more on practical side of things. So how we translate some of the research which is done in the lab into a practical product, and what are the considerations which we need to have when we are translating those products into, those technologies into real life product, or when we're trying to harness the power of technology to enable a certain application. What are the things which we need to consider in order to do that, and how we should approach such a problem, and what is the role of machine learning on the edge in the future to enable those sort of applications. So without further delay, I will share my screen if I can. Ali, am I host now? Can I share my screen or? Can you guys see my screen?
Yes, Ali.
Okay. So, as Ali said, long title, Sensing the Pulse of a City, Practical Considerations for IoT Deployments in Role of ML at the Edge. What I'll be talking about is a project which we have jointly done with a local startup known as Aware Technologies. And this project is funded by UK government GovTech Challenge Catalyst Award. So basically, the award, the way the award works is that some of the local bodies will pitch different ideas where they need help and support from technology spin-offs to government, and then government will fund those a few of those initiatives, and then the startups will bid for a pot of money to deliver the original challenge, which was put forward by a public body. So in this case, the challenge was put forward by Leeds and York City Council. And the challenge was to monitor their social housing in an effective manner to support most vulnerable people and improve the health outcomes for those people living in those properties. So as a social housing landlord, Leeds City Council and York City Council has a responsibility to maintain their properties at a certain standards, and then there are lots of regulations around that. And how can they harness the power of technology such as Internet of Things to do that? That was the main aim of the project. But the principles would generally apply to other areas, such as, for example, we were talking about agriculture, where you have lack of connectivity or limited connectivity in a rural area, you would have similar sort of principles applied. Or we talk about Industry 4.0 in some contexts, some of these principles would apply as well. This talk is mainly, we'll start with how do we extract. So mainly we'll be talking about low power wide area network technologies, LPWAN technologies. And we'll be discussing how do we harness maximum value out of LPWAN deployment, because there are things which LPWAN deployment, such as LoRa or Sigfox or NB-IoT in 5G space can deliver. So what is the maximum value which we can harness from these sort of technologies? We'll talk about what are some pre-deployment considerations. So when you want to deploy such a technology at a scale, say you want to monitor 55,000 homes in Leeds, or you want to monitor maybe more than 55,000 homes in Jordan, I would say. So it's a small scale for Jordan, I think. But yeah, I mean, when we talk about thousands of devices, what are the pre-deployment considerations? And then we'll be discussing some deployment considerations. So what are technical considerations for deploying it? What are our experiences, and what are the main challenges? And then I'll be discussing role of TinyML, which is a tiny machine learning framework in enabling some of the machine learning challenges on the edge. Okay, so we have all seen these sort of vertical initiatives, which a lot of cities want to do these days. So, you want to monitor air quality, you want to have a sustainable mobility, especially post-COVID. Given, I'm not sure whether you guys follow, but in UK these days we have a petrol crisis. So that puts a lot of emphasis on sustainable mobility and e-mobility in the future as well. There's a lot of focus on green urban areas. How do we do that? How do we sort of optimize the waste management? So all these vertical segments of smart city, people have been talking about this for a while now, like, last decade, we've spent looking at different problems in these domains. And most of these, as Professor Khalid also pointed out, require interdisciplinary work. So when we talk about energy efficiency of the building, it's not just electronics engineers or wireless comms engineers who can deliver that. It would be a close collaboration with civil engineers who understand infrastructure, how it behaves, what stimulus is, it responds to, and how that building fabric changes over time with the lived experience. So there is a lot of interdisciplinary research required in enabling all these vertical sectors. What we were interested in, when we look at all these different verticals, as I said, we were interested in a particular aspect, which was monitoring social housing in Leeds and York. But if we generalize the principle across all these verticals, there is a strong belief that data is the new gold, basically. So, you want to harness the power of data and use that data to enable all these vertical applications. So, there are lots of local initiatives. I won't go through them in very much detail, but, there are projects going on in monitoring, for example, street lighting, making it smart so that it can be repaired in a proactive manner. There are projects where people are using sensors to monitor flooding potential of certain houses, and then using the insights from that to improve the service delivery when and if that is required. But I mean, this belief that data is the new gold led to a sort of a paradigm shift, where what we have started to do is that we have said, okay, let's collect a lot of data. Forget about what we want to do with the data. Let's collect all this data, take it to the cloud. And then what we will do eventually is that we will analyze the data. Once the analysis is done, we will get the inference out of it, or whatever principle we want to extract. So let's say house is bad or good. We will extract that information in terms of inference. And then potentially that will feed into our service delivery, whether we do something about that or that house, or send somebody to inspect that house further, for example, in this case. In smart agriculture, it would be, let's collect a lot of data from crop, and then let's collect data on input and output. Let's mix and match all this data, and then let's try and what input maximize the yield without having a significant and which inputs do not have significant influence, so we can reduce those inputs, for example. Am I still audible, Ali? I have some connection issue, but should be fine.
Yes, fine.
Okay, that's fine. Thank you. So I was saying that we have started collecting a lot of data without really knowing the value of that data. So we collect a lot of data with the hope that there is some value in this data. Now, it is very difficult to predict the value of the data. You would say it's a chicken and egg problem. We don't know what to collect unless we collect it and analyzed it and have extracted some value from it. I would call this approach of collecting the data, translating it into inference, and then integrating it into service and upgrading to new service to extract the value as a bottom-up principle, where it starts with the collection of the data. Now, if we follow this approach, this means that we need to deploy the network, IoT network, to enable us to collect all the data at very high fidelity, at very high resolution spatiotemporally. A lot of low power wide area network technologies are not designed for this purpose. So, for example, when we talk about LoRa or Sigfox, it's few kilobits. It's designed to send alarms. It's not designed to monitor a property 24/7. So, we are trying to use those technologies in a sort of a manner for which they were not designed. And if we use alternatives to those technologies, like cellular or the other technologies which we have available, they do not give us the ranges we are interested in. So they won't cover kilometers. We will end up deploying huge amount of infrastructure, end up managing that infrastructure. There is a management CAPEX, OPEX cost associated with that infrastructure as well. The other problem we have is that the more we collect, the more we understand about the process dynamics. So let's say if what we put in people's home is a temperature humidity sensors, for example. If we are collecting temperature humidity data from home, we do understand when somebody was taking shower, when somebody was putting kettle on, all these kind of side information which is encoded in your sensors reading. Now, that violates the privacy of the person, where you have put the sensors in first place to monitor dampen mold growth, for example, in social housing. So in those areas, or say for worker safety, you have deployed some sensors, but then you can work out where the workers were, how efficient they were, and the sensors were not deployed to monitor their efficiency. It was for their safety purposes, for example, in context of Industry 4.0. Now, the more data you collect, the more chances are that you will end up into a territory where privacy would become an issue. So the principle we should adapt really, and what we adapted in this project, was collect just enough data. Hello? Yeah, sorry. So I was going to say that the principle we have adopted is that collect just enough data to enable better service delivery. So rather than starting bottom up, start top down, start with the value. Where is the value? So let me give you an example what I mean. Let's say we talk about air quality. So if we talk about air quality, what we are interested in is how is a measure called air quality index. Air quality index is a function which measures the pollutant concentration over time and prevalence of concentration levels in a certain area. So we are not interested in the individual sensor readings of PM10, PM2.5, nitrous oxide, O3. We are interested in whether AQI index is good, satisfactory, moderate, or very poor. So we are interested in index where these readings, the raw readings, have to be averaged over a different duration. So let's see here, these readings are averaged over 24 hours. Some readings are averaged over 8 hours. So rather than sending the raw data all the time, if we can somehow use this knowledge that whatever service delivery we need to do is based on AQI, and then we can live with collecting this data locally and aggregating it and averaging it over a spatial temporal duration, which is reasonable enough for service delivery. So let's start with the value. Where is the value? Value is in collecting AQI. Value is in, let's say, how do we want to use that AQI value? We can gamify the travel. So, travel on the routes which will minimize, let's say, air quality impact. Traffic dynamically, we want to notify vulnerable people not to travel on certain routes. We want to have call for action days. All these kind of initiatives which we want to deliver as a service are the value for us. And these value can be harnessed through just collecting AQI, air quality indexes. So we do not need to monitor all the processes all the time and transmit that over the network, which would, if we tried to do, would end up in a very unrealistic requirements for the network. Okay, so what I'm saying is that rather than starting bottom up, collect all the data, we start top down. We work out what do we need to improve the service delivery, and then we work out from that what are the requirements for network connectivity and what data we need to collect. In our case, what we wanted to do was improve building energy efficiency, for example, and we had a LoRaWAN network deployed in the city. So in order to do that, we need to address some of the pre-deployment considerations, and those considerations are mainly around scalability of the deployment. If you're deploying in 55,000 homes, then you want to consider questions like, what do you want to learn from collecting data to influence the change? So what learnings you want to start rather than starting in wild, what is the minimum infrastructure required to gather these learnings? So, okay, what coverage levels do I require? How many? This will determine how many gateways, for example, if I'm deploying LoRaWAN network in a city, I would need. What sort of technologies I can use to gather that data as well. So basically, we started. You can answer these design questions once you start from top to bottom approach rather than bottom to up approach. Again, there are lots of technology choices in this space, so one size does not fit all. As we know, you would have to mix and match. You have personal area network, LAN, WAN, and then LPWAN. LPWAN can provide you high range for your deployment. So for example, in rural areas, you can cover a few kilometers line of sight using LoRa. But PAN has its own role to play in this space as well. So for example, our solution for monitoring home relies on having sensors which have Bluetooth connection, and then a home hub which basically communicates with these sensors over Bluetooth and then transmits the data over LoRa at a city scale. So you would need to combine different technologies in different corners of this diagram. But the key principle in determining what technologies you want to combine is what do you want to basically collect in order to improve your service delivery. Okay, so LoRa, today I'm not going to talk about all these three boxes. I'm mainly focusing on LPWAN technologies, which is the green box here in the diagram. LoRaWAN, I would presume that most of you have come across this. It's quite it's a ISM unlicensed band, 868 megahertz, 433 and 900, recently 2.4 gigahertz as well. And the principle is that you can send few kilobits at a very high distance. So 22 kilometer line of sight and 2 kilometer non-line of sight with very good link budget. And the technology is designed to basically enable smart applications, which we have discussed before. The architecture is very is typical that you have end devices which communicate with gateways connected sort of managed through some enterprise network. For example, Things network is one. You have other like ChipStack, which is open source, where you can host that network yourself in some cloud service like AWS, for example, and manage it yourself. So LoRa is a radio frequency technology. It uses SPAD spectrum, low duty cycle, extended coverage, extended battery lifetime. It's optimized for performing over long duration. And the architecture is pretty much, we are all familiar with end devices, gateways, and cloud. So it's again a cloud-centric architecture where you collect data, send it on the cloud. So when we started with deployment of LoRa in Leeds, the first question was where to place the gateways, how many gateways are there? And one of the things which we could have considered, so this is, I'm showing you the current gateway deployment in Leeds, but what we did was we analyzed, we did some RF surveys, we analyzed where the gateways could be positioned. And in order to work out the gateway location, it wasn't just, generally the belief is that higher the location is, the better the coverage is, but higher the location is, the coverage will improve. But if you place them on only high locations, so say for example, red locations, this is the elevation map shown in the second diagram, then potentially it will be away from all the sensors which you want to cover effectively. So in this case, the sensors which is shown in the diagram are lamp posts in the city, where we want to monitor smart lighting infrastructure. So what you need to consider is when you're planning for coverage is where your end users will be, so where the nodes will be located in the city, and you need to consider can you find out high enough spots where you can deploy very easily. which are closer to those nodes as well. So it's an optimization problem, and I won't go into the details of how to solve that optimization problem, but there is a paper which we wrote some time ago, which covers different methods of solving this optimization problem, especially because you don't want to deploy this network for one application. So let's say these points I'm showing you are a lamppost, but you also want to cover houses in the city as well. So when you have this sort of optimization problem where you don't know the location of the sensors a priori, then what Ali has been working as part of his PhD, using the knowledge of point processes, for example, you can exploit that to optimize pre-deployment process of the gateways and work out how many gateways are required. So that's the process you follow in order to work out the gateway locations. As I said, unfortunately, high locations will improve the line of sight coverage and receive signal strength at your devices. But unfortunately, coverage is not equal to receive signal strength. So data rate in case of LoRa and several other technologies is a complex function. Particularly for LoRa, it's a complex function of spreading factor, because LoRa uses spread spectrum modulation. So it spreads the signal based on the distance from the base station. So if your device is further away from the base station, it takes more time to transmit it. You can transmit only less amount of data because your duty cycle duration is fixed. If your device is close enough to the base station, then you can transmit at a higher data rate. So energy and airtime basically increases as you move further away, but data rate decreases as you move further away. So it's not easy to work out from just optimizing signal and as we've done in this paper to optimize the coverage in the entire city. So what you need to work out is that at a particular spreading factor level, let's say you wanted to cover the entire city at spreading factor level 7, which will provide you with the bit rate of 5.47K, then what is the minimum number of gateways required at that spreading factor? And that might be much more than what I've shown here, really. So you can cover the city and you will have RSSI at a particular spreading factor level, but you would need to work out which spreading factor level do you require. And when working out that, you also need to work out what are the platform policies. So for example, if you're using Things Network, they will have something called fair access policy. In fair access policy, as you can see, if you are at spreading factor level 12, you can only send 1 packet an hour, roughly, 0.8 packets average per hour, which means you can send 1 packet per hour, and that packet can be 8 bytes in size. Now, Leeds has a network which was not covered at SF7, although it's covered, the coverage is uniform in the city, but most of the places we get SF11, SF12, so we can really send 1 packet per hour of 8 bytes, and that 8 bytes packet has to encode the information of the entire house in terms of its thermal performance. So that's really interesting challenge again. And we, as we know from information theory, we can look at how to encode and compress the packets to this extent that we can still get some value out of it, but without having a huge payload size. We are limited to what we can send. But that's a good thing, because this means that we cannot send everything, and we cannot certainly send raw data over this network to improve the service delivery, which means that we can preserve the privacy of the users using this network and basically send only limited amount of data, which is required to do that, and work that out using some of the tools which are already in our basket. The other problem which we want to do is that we cannot plan for when we are deploying in real life, we cannot plan for the best case scenario. It's always better to plan for worst case scenario. So in this case, we are planning for SF12. We don't know what spreading factor we will attain in the real life. So let's plan for the worst case scenario and basically deploy the system. Once the system is deployed, we have analyzed the data coming out, so we can measure RSSI levels from this network. Then we can work out that, if we plot a cumulative distribution function for, let's say, SNR, we can work out 90% of the time the SNR was above, say, minus 15 dB, which means that I can operate at SF10 in this area rather than SF12, for example, which I planned for. And once I have this information, I can, if I have designed my devices in an appropriate manner, so I've provisioned firmware upgrades over the year, then I can send that firmware upgrade to my device and upgrade it to transmit at SF10 rather than SF12. So we can do all that, but the design has to be aware that we plan for worst case, but we have provisions in the design to upgrade once we have observed what performance it shows in the field, basically. Again, then there are things you can do to augment the coverage. So let's say if you wanted the coverage at a certain level, there is a possibility of deploying indoor LoRa gateways, which basically allow you to augment the coverage provided by outdoor gateways. And you can get typically 680 to 1000 meters on a very simple indoor gateway from, such as this one provided by Things Network. So what we have learned from all this, bring algorithms closer to the data. So basically run the algorithms on the edge device inside the home, for example, to only get, say, triggers or alarms, for example, in our case, which you can easily send with very little amount of data payload available to you in a city. Basically that has a lower energy penalty for end devices, so you do not consume a lot of energy on the device side as well, and you can also ensure privacy and security. Now, in order to do that, basically, you need to think about how the current cloud-centric architecture needs to change. So currently, as I said, and as I've presented so far, the architecture is you take everything from end device, bring it on to the cloud, you analyze it there. What I'm saying is that you take everything, you analyze it at edge, you sort of work out summaries or some sort of a descriptor, and then you only share that descriptors with your cloud side, and those descriptors can again be used for machine learning in the cloud. So this brings me on towards ML on the edge. As I've mentioned, some of these reasons from the previous application, that the reason for doing ML on the edge is, one, power efficiency. Most IoT devices are battery powered. They have fixed power supply either doesn't exist, or power source is not co-located with where we want to do the monitoring, or plugging into mains is costly, or you cannot move the device around as well. So it's either power consideration, there is a latency consideration that if you're transmitting everything and then making inference in the cloud and then pushing, let's say if you were doing actuation as well as a part of the process, if you're pushing that inference back to the end user, then the delay encountered in doing that process is not deterministic, and you don't have control over it because your information is being sent over internet, which introduces random delays. So it's better to do this sort of processing on the edge rather than sending it to the cloud, as you can see from very simple results presented here. Privacy, we have touched upon. When you have raw data from the sensor, the more paths it traverses on internet, the more sort of chances are that it can be compromised, and you can lose the trust of your customer. Also, there is no transparency. So when you are running an algorithm on the edge, at least consumer knows that what's going out of his house and why that is going out of his house. So there is a transparency about what's being shared and why that is being shared, and which applications are authorized to use that shared data. If you run these things in the cloud, he or she doesn't have a transparency, so he doesn't know that how you would be using his information to make the inferences. So there is no explainability, there is no transparency as such in doing this. Connectivity, again, as we have seen in the previous example, if you want to deploy a huge amount of infrastructure, it's difficult and costly to maintain and such an infrastructure and provide management for it. It's easy. Local inferences reduce reliance on the connectivity. So let's say if you were operating in a rural area and if your edge device was good enough to make inferences, then you do not need to really have a backhaul connectivity for your edge devices at all. You can make a small edge network which can between itself, some of the gateways coordinate the inferences and provide reliable inferences with reliable latency to whatever application you're trying to design without relying on connectivity at all. So we need to depart from thinking about cloud-centric architecture, and we need to think about edge-centric architecture for machine learning. And this sort of architecture, basically, what it would look like, it would provide machine learning as a service on the edge. You will have some low fidelity models running on the IoT end devices. And your gateway would have three main components. You have device manager, cloud manager, and resource manager. And there are different functionalities that are basically implemented within these three different managers. So you would have device commissioning and authentication, device shadowing, all these kind of things. And I'm not going to go into details of these because it will take a lot of time to explain each functionality. But yeah, I mean, the focus here is that we need to think about how machine learning can be implemented as a service on the edge and transcend from cloud-centric approach. And one way of enabling this is through a TinyML architecture, which allows you to implement machine learning on low-end IoT devices such as microcontrollers or microprocessors, which have very low memory. So you can train the model in the cloud and then export the trained model onto end devices. That's one way of doing it. The other evolving architecture is federated learning, whereby you can distributedly train your machine learning algorithm without sharing all the information to the cloud, so that the privacy is preserved. And there are lots of applications of such an architecture, especially TinyML as a service architecture, whereby your edge exposes machine learning as a service. Starting from manufacturing, we have talked about Industry 4.0. Digital twinning is one example. Operational environment and worker safety could be another one, and especially these are some subtopics which are emerging in these particular domains. Health and assisted living is another one. Consumer IoT, I have already spoken about one of the use cases which we were working on. Infrastructure monitoring is another one. So there are lots of applications of TinyML as a service or ML as a service on edge devices. In collaboration with Ali from HashMet University, we have also done some work on implementing some of the initial architectures on publicly available devices, and also doing a small proof of concept prototypes for such an architecture.
Ali,
We have a paper.
Just take 1 minute. One of the these is asking, we are expecting more information about the machine learning projects in Jordan. I don't know how we can arrange that through another conference, or if we can provide some information for the attendees. I mean, he says, just to have a slight background of what we already have and how we can achieve some cooperation. If you, Ali, can elaborate from this slide what we are working on and what we have achieved till now in tiny machine learning.
Yeah. So what I would say is that the collaboration with Ali has been, I mean, we have done some proof of concept prototyping, but we want to extend that towards the project which Ali mentioned on the smart agricultural side. And one of the ideas we are working on in that space is using backscatter communication. So basically battery-less sensors. Again, these battery-less sensors have very limited amount of memory, and because it's ultra low power design for those sensors, then potentially you cannot transmit everything every time. So what we're trying to do is use TinyML architecture on those nodes to minimize the amount of data which we need to transmit and do the machine learning and inference on the device itself. So that's the project Jordan. I think from the local perspective, I would love to hear more about what other projects are ongoing, and potentially somebody from Jordan. I'm sure that there will be lots of exciting projects on in this sort of space going on at the moment. But yeah, I think there are a few applications which we are working on at the moment, and I'm happy to discuss the collaboration opportunities in general. But yeah, to conclude the whole thing, TinyML Tiny is the new big, basically. So tiny machine learning is a new big thing in machine learning because of its capability to be implemented on edge devices. Some key research challenges in this area are: how do you reduce the size of neural networks so that they can be hosted on small devices, microcontrollers with limited memory? Yeah, you can do some of the trivial stuff with TinyML for now, but how do you make it, if your data has a spatiotemporal relationship, for example? So those of who know self-exciting processes or data which triggers further data, for example, tweets or that type of data, events which trigger further events, or complex data relationships, let's say data which is not just time series data which has more sort of a graph representation or relationship in terms of graph. How do we implement machine learning for that through TinyML frameworks such as TensorFlow Lite? It still remains an open question. So there is a lot of research opportunity in this area. Yeah, and I'm happy to discuss that with you. Thank you. Any questions? I'm happy to take them now.
Dr. Ali?
Yes.
Okay. Thank you, Ali. It's interesting presentation and talk. And as I said before, this part of this presentation is the collaboration between me, Ali, and Massimo, and too many researchers in this field. As I can say that this machine learning or tiny machine learning is not a very old technology. It's the state of the art in machine learning. So, and this is why we applied to the Royal Academy of Engineering to intensify our collaboration for this kind of projects. So, if anyone is interested in asking any question,
yes, Ali, you have a question, please.
Yes, Doctor.
Yes, thank you, Dr. Ali. Thank you, Dr. Sayed, for the nice presentation. As you know,
you can talk Ali also.
Yeah. Excuse me?
Sorry, we lost you, Dr. Ali.
Okay. Yes, Dr. Sayed. In fact, I have one question. You know, many researchers, they address different challenges which smart cities IoT system deployment encounters, namely security, privacy, smart sensors, networking, big data, analytics, and so on. Can you comment, please, if you have addressed these challenges in your research?
Yeah, so basically, in the commercial deployment we have at the moment, we have addressed most of these challenges. And as I was presenting with the application, our approach to privacy and security is twofold. I mean, from privacy perspective, we execute everything, all the algorithms on the edge. So the principle is not to bring data to algorithms, but to bring algorithms to the data, so closer to the consumer, so that you don't transmit raw data, which potentially can lead to privacy breach. The indicators we transmit over the network are sort of encoded in a way that we use in standard encryption techniques. So in terms of commercial solutions, although academia, people have been talking about things like blockchain and things like which are bit state of the art, or from commercial perspective, we'll say it's an overkill at the moment, if we try to do that. But commercially, we use standard encryption techniques to transmit that data from devices to the cloud. What we follow also in terms of, because this is a GovTech project, we have to satisfy about 15 criterias, which are basically defined by GDS, Government Digital Services. So the criteria include things like accessibility requirements, digital inclusivity requirements as well, that, you know, not everybody can configure sensors if these sensors are delivered in the household. So, you know, what do you do about people who have no or zero digital literacy? You know, how do we engage with them? Can we build something which will just out of, you know, post box, people can put in their house and it works out of box? So those sort of requirements needed to be integrated as well. From the dashboard analytics perspective, we needed to meet accessibility requirements as well, which you know, as a researcher, we don't consider unless we are commercializing the product. So all those kind of things we had to consider when we were translating our, you know, simple solutions in the lab from lab to practice, basically.
Thank you, Ali, for your answering. I'm not sure if there is anyone else who wants to ask any question. I believe that Dr. Khalid, the Vice President, may have some thing to say about this kind of multidisciplinary, but I'm not sure if he's still with us till now. Dr. Khalid, if you...
Yeah, he's with us.
Yes, Dr. Ali. Actually, I think now we are seeing AI tool now in. I remember 20 years ago it used to be just research. Now we see AI application in all aspects of our life. So I think now there are great opportunities for interdisciplinary research, and this should be a collaboration between those who have the tool and between those who have the application, who have the real application, who have the real need. I think that I would like to see this kind of collaboration between people like in computer engineering, information technology, and all areas of civil engineering, the water, transportation, medical engineering. I think there are great opportunities if we can establish multidisciplinary work, because multidisciplinary work will be based on actual needs, and this will find a route to go to the industry. I think this should be our focus.
Yeah.
Thank you.
Thank you, thank you, Ali.
Yeah.
Ali, if you have something to say?
I was just going to reinforce what Dr. Khalid was saying, that it's really important to you know, think about these things in a multidisciplinary fashion. And, you know, Ali, as you have been working with some other students as well, like we have looked at things like smart textiles, which are a combination of how IoT integrates with you know, wearables, for example, and, you know, different medical applications, for example, rehabilitation of stroke patient or monitoring of elderly on their, you know, mattress, how often they turn, for example. So there are lots of practical applications, and the only way for making a good product or a translation out of research is multidisciplinary collaboration. So there is no, I mean, monodisciplinary kind of things. You can do your own research, but you cannot translate it into a product unless you have knowledge from different disciplines integrated. So really, you know, Dr. Khalid was making a good point there.
Thank you, Ali. Thank you, Dr. Khalid. Thank you, Dr. Ali, for all of your question and collaboration. I will leave a 1 minute time for anyone has any kind of question or just want to Dr. Ayman Mansour, Dr. or Yusuf, Hani Yusuf, they are Majid, Ibrahim. If you have anything in your mind to ask, feel free to share it with us.
Yeah, I think if you would like to collaborate in this space on any of the projects, I'm more than happy. I think my email should be on the workshop website. I'm not sure, Ali, whether you're recording this, but, you know, it's on my slides as well, so you can reach me out, and I'm more than happy to.
we are streaming live on the Facebook, and it will be recorded on the Facebook. Once this workshop is finished, we can download the recording from the Facebook and editing it and sharing it to you. So thank you, Ali, again and again and again for your support.
Thank you.
Thank
Pleasure
you for
to be here.
Again. And now we will go to Mrs. Abir Bashiti. She is an alumni of the Royal Academy of Engineering. She's an alumni also from the Faculty of Engineering in the Hashemite University, as Dr. Auni stated before. We've been partners in Jordan University of Science and Technology in our master's degree, me and Apir. And at that stage, I didn't know anything about the research that Apir was doing, especially in emotional AI, and her collaboration with the Royal Academy of Engineering in the LIF program. I will leave the floor right now for Apir to speak about her journey with of Larimar through the Royal Academy of Engineering window, and I believe that she is going to speak about emotional AI. Then we can emphasize the multidisciplinary applications of machine learning. And Apir, the mic is yours if you are ready. Apir? I think there's a...
She was attending a few minutes ago.
Yeah, she was
I think connecting, just connecting now.
Who's
Yeah,
connecting? Yes, Abir.
Assalamu alaikum. Sorry, guys. Actually, it is technical difficulty.
I think there is a problem with the network with Apir. Let's take some questions until Apir become ready. I would like to pass my regards to my ex-partner in the University of Leeds, Dr. Ihab Saleh. I think you have something to say.
Thank you, Dr. Ali. Thank you, Dr. Ali's as well, because I had a question to Dr. Zaidi. I think we have to distinguish the two now. On the ethics side of the work that you've done, especially because you've highlighted that earlier on the talk, Dr. Zaidi, about privacy. How could that be taken on board to avoid basically infringing people's privacy in that sense?
Yes, so I think GDPR, as far as so far is the gold standard, basically. But when it comes to GDPR, people just think that once the data is collected and the consent has been given for the collection of data, then that is perfectly fine. You need to have consent built into your IoT platform so that that consent can be withdrawn at any time. And the consent is for a specific piece of data for a specific purpose. So it's not like I have collected temperature, humidity data for doing damp and mold prediction, but let me offer you another service. I cannot do that under GDPR, unless I have an explicit consent for a second application, which I want to develop on top of that. So I think what is really important is, and the third thing there is that, when you have a sensor data, there are ethical considerations where, as you have alluded to, that, sensor data is objective data and it's not same as how somebody's feeling. So if I'm feeling cold, but my sensor is telling that temperature is fine, that's a subjective feeling, isn't it? And how do I cater that into my system? and can I do something in my machine learning model to take that sort of labeling on board as well and fuse that subjective and objective data in a particular manner. So in terms of the framework, when we were designing, we had to consider these things. We had to provide interfaces, which were mainly through mobile apps to allow or disallow consent. We had to be very transparent of what's being collected, why it's being collected, and what's going out of the house, what's staying on the premises, for example. So yeah, I think I think it's good to approach the whole project from ethics side, because if you don't have ethics and privacy built in, the main fundamental barrier is adoption of these devices. So a lot of people have been manufacturing these devices for a good amount of decade now. You get Alexa, AWS, smart home automation solutions, but the adaptability is very fragmented and scarce, because people don't want to use it if it serves as a big brother. So and people will only use it if they can see the benefit, and with only limited amount of sharing of data which they can do. So that was the main thing which we had to consider before designing these.
Thank you. That's great.
Thank you, Dr. Ihab, for being here with us today. Okay, I'm not sure about Apir's connection, if she gets rid of her problems with the connection or not. Okay. Any question, just to give her some time to recover her connection?
Dr. Ali?
Yes, Dr. Ali.
In fact, I have one comment. I have one question. I'm not sure if you or your colleagues in this project, if you addressed in your research directions the pandemic and the AI and IoT and smart cities. Have you addressed the pandemic?
For me, I've not yet addressed this kind of issue in the pandemic for COVID-19, but I'm sure that Ali from Leeds had, I believe that he addressed some kind of proximity analysis and data analytics for detection number of peoples to ensure social distancing in homes.
Yeah, because when we are talking about the smart cities,
yeah,
the pandemic, yeah. Hello?
Ali,
Hello, Ali?
yeah, we can hear you, Dr. Dr. Arni, do you have any?
I think Dr. Oni was asking about initiatives which basically connect smart cities to COVID, post-COVID recovery as well. So yeah, I think what we when the pandemic started, most of the academic basically put their main academic research aside and tried to contribute as much as they can. So what we started looking at is in UK and most of the European countries, we came up with the app-driven solution, which was around contact tracing. And then there was a huge debate about distributed versus central. And there was a debate about privacy as well, that whether you implement a particular contact tracing app in a way that all the contacts are stored locally and they are only uploaded once you have tested positive by your consent. So again, brings back to the privacy point. And then there was a sort of a group of people saying that this needs to be implemented in a centralized manner, whereby all the contacts will be shared centrally, but will only be decoded once you have tested positive. So we started looking at that. Again, a lot of people were doing Bluetooth-based contact tracing, and then other solutions also came on the market, like people tried to use ultrasonic beacons from your smartphone. Other people also propose ultra wideband technologies, which have better localization resolution. So a lot of different solutions evolved over time. But yeah, I think one of the things which we looked at was adaptability of these solutions. And, there was, I think Oxford reported that if 20% of the population installed the app, then you would be able to capture maybe 60% of the cases. But I mean, this sort of analysis is not really, basically or something which we started to look at. And yeah, we simulated mobility models, but I think there is a huge vacuum in understanding mobility in different cities, and for different type of people as well. So, certain people in certain occupations will be exposed to more context than other people. And the dynamics of the city itself, like, I come from a city in Pakistan called Karachi, where we have a few million people, and one person will be exposed to few thousand people in a day rather than few 10 or 20 people in say UK, for example. So there isn't a huge amount of data available on urban mobility, number of contacts. And when this one thing which this pandemic has alerted to us is that there is a huge need of collecting those sort of data in order to make policy decisions, that which areas to shut down, how to shut down, should it be consistently a lockdown or an intermittent lockdown. And there is a huge opportunity to do research in that area and combine it with machine learning, smart cities aspect as well.
Thank you, Ali. I'm very sorry for this disconnection. Yes, I agree with you. I believe that the pandemic and the COVID-19 is one of the main attributes that should be addressed when we are talking about smart cities. So thank you, Ali.
Thank you, Dr. Oni. Thank you, Ali, for this collaboration. I will give my presentation instead of engineer Appier, and we will wait for her to recover her connection. For answering the question, what we are doing here in the Hashimite University and the Department of Electrical Engineering in the Hashimite University. This is one of the titles that are under the title of the project, and it's called Sky to Edge Machine Learning Drone Assisted Transfer Learning Model for Smart Agriculture. So here we are talking about many things, sky to edge. So how we can transfer our knowledge that we made on the cloud or on the centralized computers or in the fog also to the edge devices. Because as we stated before, as what Ali stated before, that what we are doing here is making the inference and the prediction or the regression on the edge. But do we have capabilities on the edge devices to make the model or to build the learning model? So from this point, we agree that the ultra low performance devices on the edge can do this kind of training to transfer and to federate the learning. But here we assume that we have a centralized database, a centralized computer which is doing the training and building the model for the machine learning or the artificial intelligence. And then we want to deliver these models, the ready models, and transfer them to the edge devices, the edge devices in some kind of applications like smart agriculture. So using the techniques that we have. So for example, what if we want to deliver this transfer model using drones? I want just to remove this eraser. I'm not sure about this line here, if it's appearing on your screens or not.
Yes.
Yeah.
That's fine.
Okay, that's fine. Okay, So in this presentation, I would like to emphasize some of the aspects and some of the bullets that Ali said and presented in his talk. Edge intelligence use cases, what is the edge computing challenges, or what are the edge computing challenges? I will show you some of the designs for sensors that we've made here in the Hashemite University using the efforts of our undergraduate student and in their projects for the 5th year. Sensor design, and I will show you very brief results that we achieved in this edge intelligence. So, for example, why IoT data analytics has to be real time at the edge. So, at the edge, we can achieve volume and velocity, ingesting, processing, and storing such huge amount of data, which is gathered in real time. So we can't save and transmit all the data that we have on the edge to the cloud because of the congestion that we will make, especially if we are talking about a huge number of sensors. They are working together or working to do some inference and transferring their knowledge to the cloud. Security is one of the things and important things that we achieve when we are talking about edge computing. Devices can be located in sensitive environments, control vital systems, or send private data. With a number of devices and the fact they are not humans who can simply type a password, new paradigms and strict authentication and access control must be implemented to achieve this security issues. The bandwidth, if devices constantly send the sensor and video data, it will make a huge to the internet and cost. So therefore, edge analytics approach must be deployed to achieve scale and low response time. So real-time data capture, storage, processing, analytics, knowledge, discovery, decision-making, and actuation are also one of the most important things that we are looking towards implementing machine learning on the edge. Less latency and faster response is also one of the crucial things. So if I have something that I'm monitoring on my hand using a smartwatch, do I need to transmit all the data to the cloud computer and then wait for the response from the cloud computer after the inference to know what is the thing that I'm doing, what is the target, or what is the classification output that the cloud will send to me. So if we implement machine learning on the edge, we will have less latency and faster response. Context awareness capability and combining real-time data with historical state. There are analytics solutions which handle patch quite well, and some tools that can process streams without historical context. It is quite challenging to analyze streams and combine them with historical data in real time. The edge computing challenges. Any IoT environment is hugely dynamic and stuffed with a large number of edge and fog devices, if we are talking about fog devices. Every device is to be placed with one or more RESTful APIs, and anyone who is from the background of computer engineering or computer science know what is the meaning of RESTful APIs and multiple RESTful APIs to be implemented on the edge to achieve a certain objective in the edge. So fog, edge, device discovery, governance, management, integration, orchestration, and security are also some of the challenges that we are facing with edge computing. Mapping services, applications with edge devices, leveraging fog computing for scalable IoT data center using spin leaf network topology. Edge device traffic management is not also an easy thing, especially when we are talking about very far locations for the inference. Data and protocol translation, forming clouds out of edge and fog devices. The industry use cases of edge computing. So as I said before, there is a multidisciplinary applications for machine learning and edge computing. We can talk about drone flying robots and manned aerial vehicles, UAVs, and surveillance and instant delivery. So for surveillance and instant delivery, edge computing facilitates the monitoring, measurements, and management of drones. In smart cities, integrating data from a diverse collection of municipal systems, street lighting, traffic information, parking, public safety, or etc., for interactive management and community access is a common vision for smart city initiatives. However, the sheer amount of data generated requires too much bandwidth and processing for cloud-based systems. Edge intelligence provides a more efficient solution that distributes data processing analytics to the edge, where sensors and data sources are located. When we are talking about connected vehicles technology adds an entirely new dimension to the transportation by extending vehicle operations and controls beyond the driver to include external networks and systems. Edge intelligence here and fog computing will enable distributed roadside services such as traffic regulation, vehicle speed management, toll collection, parking assistant, and more. In manufacturing, from creating semiconductors to the assembly of giant industrial machines, edge intelligence enhances manufacturing yields and efficiency using real-time monitoring and diagnostics, machine learning, and operation optimization. The immediacy of edge intelligence enables automated feedback loops in the manufacturing process, as well as predictive maintenance for maximizing the uptime and lifespan of the equipment and the assembly line. In oil and gas extraction, which is, I think, not the case of Jordan till now, but we hope so, are high-stakes technology-driven operations that depends on a real-time on-site intelligence to provide proactive monitoring and protection against equipment failure and environmental damage. Because these operations are very remote and the lack of reliable high-speed access to the centralized data centers, edge intelligence also provides on-site delivery for advanced analytics and enable real-time response required to ensure maximum protection and safety. In mining, conditions in very remote locations with little or no access to the internet. As a result, mining operations are relying more and more on edge intelligence for real-time on-site monitoring and diagnostics, alarm management, and predictive maintenance to maximize safety. Operational efficiency is a crucial thing, and to maximize costs and downtime in the mining. In transportation, as part of the race in the industrial internet, trains and trucks, buses, aircrafts, and ships are being equipped with very new generation of instruments and sensors generating petabytes of data that will be required additional intelligence for analysis and real-time responses. Here, edge intelligence can process this data locally to enable real-time assist and monitoring and management for to minimize operational risk and downtime. In power and water, the unexpected failure of an electrical power plant can create substantial disruption to the downstream power grid. The same holds true when water distribution equipment and pumps fail without warning. To avoid this, we come with edge intelligence that enables the proactive benefits of predictive maintenance and real-time responsiveness. In renewable energy, new solar, wind, and hydro are very promising source of clean energy. However, constantly changing weather conditions present major challenges for both predicting and delivering a reliable supply of electricity to the power grid. Edge intelligence enables a real-time adjustment to maximize power generation as well as advanced analytics. And more in healthcare and retail, smart building, security cameras, location-based services, gas transmission, and this distribution, in device manufacturing, we can see edge intelligence and tiny machine learning as one of the most important technologies that can provide analytics or data analytics on the edge. So what we are doing here in the university, in the Hashimite University, is sky to edge machine learning as an example, drone-assisted transfer learning. So there is a paradigm of transferring knowledge from the cloud to the edge devices through multiple kind of technologies, from fog computing into IoT edge machine learning, into what we are seeing on the physical layer of the sensing process. So I don't want to go into all of these details because I want to leave the time to Mrs. Apir, but I want to show you an examples of what we have achieved in the university, in the Hashimite University. These are three sensors that we had built in the Hashimite University using the efforts of the graduation students, undergraduate student projects. For example, the left one here in the left is a soil moisture sensor that had been calibrated, built, designed, and assembled here in the Hashimite University. It consists of soil moisture sensor, temperature sensor, air humidity sensor, and an ESP32 controller, which is enabled with machine learning algorithms. A tiny 85 controller is one of the smallest and ultra low power and capabilities controller, even though we can also enable some kind of algorithms, machine learning algorithms, on this kind of very tiny controller. This one on the left comprises MSP 430 controller, which also is enabled with machine learning algorithms. This is very interesting one. It is a very ultra low power and ultra low performance in the same time, and it is harnessing and using the backscatter technology to transmit and modulate the data into the air. And for this one, when we operate the controller on a 232 battery, which is a coin cell battery, it can operate for more than 3-4 months without any kind of changing. And if we see this using power harvesting from solar cells, then we can put this kind of sensor in a very remote areas and get some inference from it. And for more than a year, if you use deep sleep modes of the controller. So these sensors are custom made. The components, as I mentioned before, are assembled here in the university. We have soil moisture sensor. We have built and enabled the machine learning technology on the edge. Anyone who is working on deep learning knows and will be familiar with this type of networks. And I will show you some results on what we have done on this ESP32 controller using edge technologies. If you see this, we have a fully connected deep neural network. It's a feed-forward neural network. Consists of multiple neurons in 2 by n, 40 by 2, 2 by 2, and the output layer is consists of 2 by 2 input-output model. So if you see this, we are aggregating the data from the sensors, sending them to the cloud, and then do a long time short memory and feed forward network neural network modeling, and then transfer the model, the learning model, or the prediction model, or the regression model, to the controller. And as you can see, transferring knowledge, this curve shows the soil volumetric water content, meter cube by meter cube. And we, as you see in the blue curve, this is the ground truth data, which is the real data. And we claim that we can do some prediction for future values of humidity on the soil, only using the previous data that we have after training the model on the cloud. So we only train the model one time and send the model as a hexadecimal file to the sensor, and then the sensor will use this model to predict, inference, make some regression on real time on the edge without sending any private or a huge amount of data to the cloud. So when we look to the training prediction or test prediction or validation prediction, as you can see, there is a very accurate results in the prediction from site 1 to site 2. Here we have site 1, we train the model on site 1 and use the same model on site 2. There's some correlation between site 1 and site 2, but it's not a correlation of 1. It's a fraction of 1, but still using this kind of transferring the models from site 1 to site 2 using drones give us a very accurate results in predicting humidity in future data. For example, these are the KPIs that we achieved. If we train our model in site 1 on the humidity data in this architecture of the neural network, we will have a model of 5.8 kilobytes, and the inference time on the edge is 0.237 seconds, which means that the inference is in a real time. So with accuracy in the coefficient of determination, R2 is more than 95.6%. When we are talking about transferring the model from site 1 to site 2, we predict that the accuracy will lower somehow, but it's not that much. It goes to 93.2%, which is a very acceptable percentage of accuracy. When we do the transferring of the knowledge from humidity in site 1 to the temperature value in site 1, since there is also a correlation between humidity and temperature, we also can achieve a very interesting and very promising accuracy, about 96%. If we increase the number of nodes in the architecture of the deep neural network, we predict that the model size that we need to transfer to the edge is larger, but this amount of larger model size becomes with a higher accuracy, in 96.1 accuracy in the R2 measurement. So it's up to you. It's up to the performance of the controller that you are using. If you want to use this architecture of the network or this architecture of the network, if you want to transfer the humidity trained model to the temperature trained model, it's entirely up to you. But you will have some constraints on how much memory you have on the controller and what is the speed of the CPU or the clock on the controller. Given these constraints in your mind, you can manipulate and tune the hyperparameters of the deep neural network on the cloud, and before sending it to the edge devices, you can also predict what kind of accuracy, what measures of accuracy or KPIs that you will gain using these trained models. This is the end of my talk, and I hope that I gave you some informative information about our project, and I'm open for any question that is going in your mind. Any question?
Dr. Ali, I believe Abir, she's available.
Yeah, she is here. And then lastly, we have a talk from Engineer Abir. As we said before, she is an alumni of the Hashemite University. We was in the master's degree together in the Jordan University of Science and Technology. She is an alumni of the Royal Academy of Engineering. She wants to share her experience with the Royal Academy of Engineering in Larimar company in the field of emotional AI. Up here, you are more than welcome, and we are very happy that the connection is good right now. The mic is yours, and you are to.
Thank you very much, Dr. Ali, and thank you all. Actually, I'm traveling, that's why there is some issues with the connection. Anyway, I have a quiet place now, so it will be just a minute. You see my screen, right?
Abir, your voice is the connection is so bad. I think, and I believe, if you disconnect the camera, things will be better. So we still have some problems with the connection on the base side.
Hello?
Yes, here.
Yeah, good. Yeah, can you see my screen?
That means make host.
Yeah, you see my screen, right, Ali?
Just a couple of seconds. Not yet.
Okay.
Yeah. Now.
That's right.
Yeah, that's good. Okay, Larimar is an emotion AI-based startup that aims at enabling emotions through empathized technology and mentoring. We started working on Larimar as a research, and I will go through the journey of Larimar as it like a high-level description of the journey. I am passionate about the emotions in general and how we can use our emotions to embrace our life experiences. And actually, the startup started as a curious question in my head about how we can be more at ease and avoid any toxic culture within the organization or a company. And I started working and digging deeper into the idea of emotion creations and how our emotions affect our behavior and attitude. So our vision at Larimar is to emphasize technology by providing individuals and organizations a tool that can help them to embrace the uniqueness of emotions, which is enabling the use of emotions in the decision-making process in different use cases like education, gaming, security, and healthcare and well-being, which is our focus now. We do this by adding an emotional layer based on emotion AI technologies in the decision-making process. This will equip people and organization with practices and tools to embrace the uniqueness of our perception as humans, which is the emotional decision-making process. We started, as I mentioned, as a research. It was not about building a startup or building a company. It was about building a bank of emotions with different signatures for categories of youth and people who suffer from dementia, autistic children, and many others. So the journey started from 2010 and until 2017 we got different we published papers and a book, and we got some provisional patents and working on the US patents. We collected real data and many other related activities for research and development. After that, we started a journey of in the entrepreneurial world by building our skills in entrepreneurship and collecting more real data in our induction lab that is built in-house. During that, we had different training and internship round to build the awareness of well-being and how we can use our emotions for better life experiences. Starting from 2020, we had the opportunity to be one of the Royal Academy of Engineering Fellows in the Leaders in Innovation Fellowship Program, and we are the Jordan champion, shortlisted in and won different competitions. And based on that, we built our strategic planning development schema. And now we are focusing on penetrating the market after building our skill set of planning and development through crowdfunding campaign that we had on Kickstarter, and the other one that is now available on Indiegogo crowdfunding campaign. And hopefully, inshallah, by 2022, we will start generating a profit. So what is about the Larimar or the technology behind Larimar? Larimar started, as I mentioned, as a research, and through the research, we have built it different steps of towards building resilient individuals and coherent environments. That is started from self-discovery journey and building your emotional agility muscle, embrace heart intelligence and building a wise mindset, finding your edge, which is your singularities, then draw your trajectory. These all are embraced within our knowledge base emotion AI engine. But what is the impact for such technology? Based on the research that we are building our technology on, and it's mainly from HeartMath Institute and others, it will affect the body base, it will affect the organization, motivation and stress management, and ultimately it will build coherent and resilient environment, which is our ultimate goal. This is our position in terms of AI technologies. We provide mainly these types of artificial intelligence technologies that is related to responsible AI, insight engines, and emotion AI that is connected with edge components. So what we are offering in the startup, we are offering 3 types of services, starting from a solution or a software that is a web service and the mobile apps and associated. The mobile app is associated with existing wearables like Huawei, Xiaomi, and other wearables. The second type of services that we started working on is the special purpose wearable for autistic and dementia patients. Still, this service is under development. We have just the mock-up of the wearable. And the revenue generating service that we have is a coaching and consultation related to the emotional intelligence in general and how we can embrace such techniques and tools into our daily lives. Then we can use these as building blocks for technologies. What is the use cases of Larimar? Different use cases for Larimar, and our focus now is the healthcare and well-being, because our emotions is directly connected with our behavior and attitude detection. Still, we need a lot of data to do that. That's why we pivoted into healthcare and well-being. Here are some people who can benefit from Larimar services, like gaming companies, employees, and customers within the SMEs and social media platforms. Our focus now is the universities and the schools students. This is the first use case of Larimar that I'd like to dig deeper into, which is WellShift. WellShift is a mobile app and a web service that is associated with a wearable and can detect your emotions and provide the relationship between these emotions and your productivity and performance, then provide you with a tailored action to cope with tough emotions based on your rhythmic behavior. And what we are trying to solve here is the problem of stress, the increasing stress level, and how mental disorders is sometimes contagious in this world, especially after COVID. And of course, to reduce as much as we can the economic cost of poor culture within the organization. Here is a mock-up of the journey for the WellShift app. It's not launched yet. Hopefully by November, inshallah, it will be launched. Here is the mind map of the journey for WellShift. We are using vitals from the wearable. We are using natural language processing techniques for the multiple choice and narrative questions within the journey. We are building awareness so that people know more about the importance of embracing emotional agility and building well-being. And also we have behavioral data within our input, such as writing pace and the accelerometer of the device that we are using, because all of these inputs are directly connected with our emotional status. Here is the people who can benefit from WellShift, and our focus now are students and post-stress disorder patients and elderly people. Again, what we are looking for is to build success for individuals and organizations within the use case that we are tackling now, based on building impact and having an agile development schema where individuals and interactions are important than processes and tools, and of course, equip individuals with self-care practices and tools. For organizations, we are working on different pilots, pilot projects within universities to build these 5 skill sets, which is called people profit chain within the organization, and using such tool like WellShift and the practices that we are building through our research embraces and boosts these KPIs. This is another benefit of using such emotion AI tools, whereas a hard unit can be built with an organization. It's a unit that embraces the interaction and communication and having a mentor within the organization and utilizing the technology within the organization so that we have a hard unit to increase and boost productivity and performance for individuals, because ultimately it's all about the people within the organization who can build the organization with the leaders. Our supporters through this journey are of course, the Royal Academy of Engineering through the Leaders in Innovation Fellowship Program, and the partner, the Jordanian partner, the IRDF, and of course Newton Khalidi Fund. And I'm incubated at HTU, Al Hussein Technical University, at the technical incubator of HTU, which is the core. We have partnerships with, after my fellowship with the Royal Academy, we got several partnerships with Cass Business School, Godmore, and many other universities who are interested to complete with us the research and building the awareness, whether in Jordan and in the UK. Through this journey, we had the privilege to be the LEF champion, and we got accepted in different competitions. Of course, this work is a teamwork. I'm the founder, but there is a great team behind all the work. Some of them are physically with me, and some of them are working through Upwork, Adnan, Daniel, and many others. So this is a teamwork, of course. And I'd like to share the reward of such a journey. Actually, we had 3 main rewards through this journey, which is building the authentic relationship with like-minded people, especially in the UK and Jordan. And we had now sustainable growth strategies that we can build on. And finally, we have built a state-of-the-art science and technology, and we are working on building on that by using the existing technologies. Learning lessons related to my journey is make sure that you are building your capital, meaning capital, intellectual capital, and emotional capital, and the human or social capital by building authentic relationship. And of course, without having mentors, I think it was very difficult for me to go and navigate this journey. And always be reflective within this journey so that you can learn from your mistakes and embrace that and go forward. Final thoughts related to the journey of emotional AI and emotional intelligence in general is that I found every interaction with organizations or individuals, these are the main thoughts that we found the impact on people and the performance of the organization. One of them is related to raising your self-awareness through a reflection and embracing technologies that helps you do that, and always seek and provide help because we are all in a need of help, and we can provide value and contribute. And believe in your own capacity to cope in tough situations, because through this journey there is a lot of setbacks and pitfalls, but believing in our capacity to cope and the value that we can bring on the table helped us to go forward. And of course, having a spiritual connection that we can reflect on is super important. I'm available, and our office is at the core at HTU at King Hussein Business Park. And here are our social media channels that you can go through. And thank you again, Dr. Ali, Dr. Aouni, and all the esteemed guests for having me.
Thank you, Engineer Pierce, for this presentation and talking about your journey through with the Royal Academy of Engineering. I would like to give the chance to the audience if anyone of you have any question to appear about her journey, what she has learned with the Royal Academy of Engineering, and the opportunity that they gave to her in the last 10 years during her journey with the Larimar. I leave the space for you if you want to ask any question. Okay, so since there is no questions, thank you, Abir, again and again for your support and for this talk. Thank you all, the audience from all around the world, from UK, from the Gulf, from Jordan, from USA. And thank you for making this workshop a successful workshop. And we now go to conclude this workshop and say thank you again. And keep tuned with us for our next workshops. On the email, I will send you a feedback email, and I'm happy to hear from you any suggestion, any feedback about this workshop, and what things that you are looking forward to see in the future workshops. Thank you again, and goodbye.